Welcome to our first lecture on probability concepts. Today, we are going to be discussing about permutation and combination. We call it further permutation and combination because you have been introduced into this course, into this subject, and at your first year when you were taking STA 112. By the end of this course, you are expected to have understood the concept of permutation and combination and its application into solving statistical problems. As a way of starting, what do we call permutation? Permutation is all about arrangement. How do we arrange? What do we need to arrange? And what are the importance that we have placed on arrangement in count technology or techniques as far as probability concept is concerned? I start by introducing the formula for computing permutation to you. And the formula is given as n permutation r, which equals to n factorial divided by n minus r factorial. The concept of factorial has also been taught at your first year level, but as a way of recalling this, let us go into the concept of factorial. When we say n factorial, what does it mean? N factorial means multiplying n by n minus 1 by n minus 2 until we get to 1. And by example, let's say we're looking at 5 factorial. 5 factorial equals to 5 times 4 times 3 times 2 times 1. So if this is 5 factorial, what will be 3 factorial? 3 factorial will be 3 times 2 times 1. Now you can see how this reduces up to 1. Now, having said this, it is easier for us to then apply our permutation formula where we talk about n factorial divided by n minus r factorial. Here we are talking about selecting from n factorial, taking our numbers from n observation. Now, let's say we have 5 observations. For example, we have 5 letters, taking 2 at a time. What are the numbers of arrangement that is possible in this? This will be 5 permutation 2. Okay, and this will give us 5 factorial divided by n, where our n is 5, then minus 2, where our r is 2 factorial. And this will be 5 times 4 times 3 times 2 times 1 divided by 5 minus 2 is 3. That is 3 factorial, 3 times 2 times 1. So we can cross out this. Then we are left with 5 times 4, which is 20. So this means that what we have, if we have 5 letters and we take 2 at a time, we expect to have 20 of such arrangements. Having said that, let's say, for example, we have 3 letters, okay? Letters A, B, C. And we are looking at the possible arrangements that we can have, okay, that we can create from these 3 letters. Of course, we can have ABC itself, we can have ACB, we can have BAC, we can have BCA, we can also have what? If you guess correctly, then we know we can have CAB and we can have CBA. These are the total number of arrangements that is possible when we talk about permutation. Hence, the formula n permutation r equals to n factorial over n minus r factorial. Another thing that is very, very important here is a special case of this arrangement, and that is when we have taken n observation from n. And in looking at this, what is likely to be our result? This is talking about n permutation n. And this is a special case of permutation that requires that we have n factorial divided by n minus n factorial. And this equals to n factorial divided by 0 factorial, which equals to n factorial. And why is this n factorial? It is n factorial because 0 factorial is equals to 1. So each time you see 0 factorial, you should know that your answer is what? 1. Then, meaning that if you have 2 factorial, this will be 2 times 1, which is 2. If you have 3 factorial, it will be 3 times 2 times 1, okay? And this will be 6. So, having said that, let's consider another example on this. Let's assume that we have 4 balls, 2 black and 2 whites. And our interest is to know how many arrangements are possible here. Okay? Now, with these combinations that we have, then the possible arrangement that we can have here is to have black, black, white, white. Of course, we can also have black, white, black, white. All right? We can have black, white, white, black. Now, I believe you are thinking along with me on the possible combinations or arrangement that we can also have from here. We can have white, white, black, black, and we can have white, black, black, white. So this is extremely very important for you to note. And I give another example. Let's say we are interested in how many arrangements we can get from letters, especially letters that are repeated, okay, that have repetition in them. Now, if we have arrangements or observations or letters that have different letters repeating itself, the proper way of obtaining our combination here is by computing n factorial divided by n1 factorial, n2 factorial, n3 factorial up to nk factorial, where n1, n2, n3 up to nk are the total number of letters that are repeated in such arrangements. Now, let's say, for example, we have calculus. Okay, if I look at calculus here, we have how many letters? This is 1, 2, 3, 4, 5, 6, 7, 8. So our n equals to 8. And in this 8, we have n1, which is our c. We have 2c, 2. A is 1. We have L to be 2. Then we have U to be 2. Then we have S to be 1. Okay? Of course, we can count 2 plus 2 plus 2, that's 6, plus 1, 1, that's 8, to make the 8. Now, what do we do here to calculate the number of arrangements, okay, in this kind of situation? Just like I said earlier, that our n permutation R is n factorial divided by n1 factorial, n2 factorial, n3 factorial, up to nk factorial. Then we have that 8 factorial divided by, we have 2 of n1, which is 2 factorial, 1 factorial, then 2 factorial, then we have 2 factorial, we have 1 factorial. So this makes 8. Of course, we can then compute this. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial, 1 factorial, 2 factorial, 2 factorial, 1 factorial. Of course, 2 factorial here is 2. You can cancel this 2. All right. This 2 factorial here can cancel here, remaining 2. All right. This other 2 can cancel here. Then we have left 8 times 7 times 6 times 5 times 3. And if you do your calculation properly, okay, that will give us the answer that we expect in terms of the number of arrangements. So when we're talking about arrangements, some of the things that we have to put in mind is that the basic formula, permutation formula for computing different objects should be noted, and the role of factorial in counting should also be noted. And like I mentioned the other time, the special cases with identical element is also meant to be noted, because this is very important, especially in solving practical problems. That will be all about permutation.